Welcome to Brain Vision.
Part A of this problem is asking what the velocity is after the blocks have traveled 3 centimeters. So I've already drawn the free body diagrams for both the blocks. In block A, we have tension moving to the right, gravity down, normal force up, and friction force left. And in block B, we have tension up and gravity down. And now we're going to apply Newton's second law in the y direction for B, and in both the y and x direction for A. My coordinate system will be that this is the positive x direction, and this is the positive y. And the way the block's set up is I have a block here, that's A, and then it's hanging over a pulley here down to block B. And so let's start with block B. Newton's second law in the y direction there tells us that tension minus mass of B times G is equal to mass of B times acceleration Y. Remember, these things are accelerating, so we can't necessarily set that equal to 0. This implies that tension is equal to mass of B times acceleration Y plus G. And I'm going to label this equation by star because we're going to need it later. Now, the sum of the forces in the y direction for A is equal to mass times acceleration in y direction for A, which is 0 because block A is not leaping off the table. That directly leads to the fact that the normal force is equal to the mass of A times G. And so we get that from Newton's second law in the y direction for A. Now, sum of the forces in the x direction is equal to mass times acceleration in the x direction. I'm going to do this for A again. So for A, yields. Well, we got tension moving to the right, force of friction moving to the left, and this is equal to mass times acceleration. And this implies, ultimately, that mass of B times acceleration y plus G minus coefficient of kinetic friction, mass A times G, is equal to mass A times acceleration in the x. Now to go from here and here, I just plugged in what the tension I found in this step here. And then I also plugged in that the force of friction is equal to mu k times n, and n is this thing here. And so if you do that and you simplify, you get down to this expression here. Now there's one thing we have to note, and that's if block B is moving in the negative y direction, so this is acceleration y for block B, and acceleration of A here is denoted by AX, and it's moving in the positive direction, then AX is equal to negative AY. Because their accelerations will be equal in magnitude, but B is moving in the negative y direction, whereas A is moving in the positive x direction, just because of the way I set up my coordinate system here. And so, remembering this, we can simplify this expression, because we ultimately want to solve for the acceleration, but we have AX here and we have AY here. So we're going to use this to combine them and get one expression. In this case, I'm going to keep AY. I'm going to move to the next page here. And I find that AY is equal to mu k mass A times G minus mass B times G over mass A plus mass B. Plugging in all of these knowns that we already know, we get that this is equal to negative 3.3 meters per second squared. It's good that it's negative because our intuition tells us that block B is going to move down, which is in the negative y direction. Now this, of course, means that the acceleration in the x direction for A is positive 3.3 meters per second squared. Now we can use the kinematic equation. We know that the distance traveled is 0.03 meters. It's given in the problem. A is 3.3 meters per second squared. I'm going to use AX here. Initial velocity is 0. Final velocity can be determined by this kinematic equation. Plugging in what x minus x naught is and v naught, and then taking the square root this gives that v is 0.445 meters per second. And that's the final answer to part A. Part B is just asking for the tension. If you go back to the equation I starred on the first page, it's this right here. And now we know what the acceleration in y is, we know what the mass of B is, and we know what G is. And so we can plug this in and we get 17 newtons. And that's the final answer for part B. That's